Hello, I'm Seema and welcome to part 2 of the chapter Alcohols, Phenols and Ethers. In this video, I'm going to be telling you about the nomenclature of alcohols and phenols. That is, how do we name alcohols and phenols? As you have already studied the Iupac nomenclature in grade 11 and you've studied it in details, I would not be going too much into the rules. I will assume that you already know Iupac nomenclature. Yet, this would just be a little brushing up of what you've already done. In case you do not follow what I am going to be telling you, I would recommend that you go back, study that chapter of Iupac nomenclature first, of the nomenclature of organic compounds, and then come and do the Iupac nomenclature of this. Not wasting any time, let me start with it straight. As I told you that there are two ways of naming a compound. One is the common name and the other is the Iupac name. The common name may be local to a place. It may be a name that may be according to the language of the people of that area. Because every substance, every chemical, whether it is organic or inorganic, we all name that substance. There is some name that we give to it. For example, we call coal coal. Coal is basically carbon. Or we call diamond diamond. Diamond is also pure carbon, even purer, much purer than coal. And the way it was formed, only the bonding in the case of diamond is different. It is a crystalline substance while coal is an amorphous substance. So that we go into the details later, but we give them some common names. But to a scientist, both coal and diamond would be carbon. Anyway, so common nomenclature usually is according to the area, the commonly known name of a substance. So common nomenclature does not follow a definite rule or a definite pattern. It is according to whatever was seen and the name was given. It does not mean that common nomenclature does not have certain rules and certain patterns that have been tried, that people tried to follow, yet they do not have a strict rule book to name every compound. But Iupac nomenclature, on the other hand, is based on a very systematic method of writing down the names of organic compounds. So we'll take alcohols first and we'll see how alcohols are usually named, given the name in common nomenclature, and how do we write the Iupac nomenclature of alcohols. In the common nomenclature, the general convention is that you write the name of the alcohol and you end it with alcohol. For example, the alkyl group is, for example, take this methanol, right? This is CH3OH. This is a methyl group and it is alcohol. OH group is known as the alcoholic group. So it is called, in common nomenclature, it is called methyl alcohol. If this was the ethyl group, it would have been called ethyl alcohol. If it was propyl group, it would have been called propyl alcohol. So the alkyl group and the word alcohol is added normally in common nomenclature. There are many other variations like iso, normal, secondary. We'll come to those terms later. So common nomenclature can appear to be more complex because of course it is, since it does not follow a very set sequence of rules. Iupac nomenclature, on the other hand, being very systematic, will take, the basic rules of Iupac nomenclature. The first step is to choose the longest chain, which is known as the longest chain rule. Then you find the substituent. To which carbon is the substituent attached? The substituent or the functional group. And you try to allot that carbon the lowest number when you are naming the compound. We'll get, I'm not going into details because I'm assuming you know all this already. So let us take some examples of alcohols and see how they are named commonly, what is their common name and what is their Iupac name. But what is the general rule? As I said, in the case of common name, we write the alkyl group and we finish it with alcohol. And generally for IUPAC name, when you're writing the IUPAC name of an alcohol, an alkane, that is the parent hydrocarbon, the alkane, OL is the suffix that we use. But for the alkane, we remove the E. For example, this would have been methanol, may have been obtained from the parent hydrocarbon methane. So the E of the methane, last E is removed, and in place of that, the name of the functional group, that is OL. So all. So it is methane, so we call it methanol, methanol, right? And if it was ethane, CH3, CH2OH, then it would have been ethyl alcohol in common nomenclature. And in IUPAC nomenclature, we would have called it ethan, ETHAN. The E will be eliminated. Instead of E, we write OL. So it will become ETHANOL. That is ethanol. Now come to this compound, CH3, CH2, CH2OH. The alcoholic group is here. This has 3 carbons, so it must have been obtained from propane, so it is basically propanol, right? Now the OH group, in the case of methane and ethane, the OH group would be present on the first carbon because you cannot give it a locant. It is only when you have carbon chains more than 3, it becomes important to specify which carbon is the OH attached to in IUPAC nomenclature. But in common nomenclature, what do we call this compound? It is known as normal propyl alcohol. Why normal? In common nomenclature, when a compound is a straight chain, we call it a normal compound. So this is called normal propyl alcohol because it must have been obtained from propane, or the alkyl group is propyl group or propyl group, and it is normal because it is a straight chain, there are no branches, so it is a normal propyl alcohol. But in IUPAC nomenclature, how will we name it? We will start counting which is the longest chain. The chain consists of 3 carbons, so it is propan and it is propanol. And the ol is attached to which carbon? I told you that whenever we choose the longest chain, we always give the substituent or the functional group. The carbon that has the functional group or the substituent we try to give it the lowest number. That is, we count from that direction. We give it the lowest locant. It is called the lowest locant rule. And later, when you have more than one substituent, we call it the lowest sum of locants rule, which of course I'm sure you already know, and otherwise we will be coming across such compounds too. So this in IUPAC nomenclature would be propanol, but ol is on the first carbon, so we call it propan. We give a hyphen, we give the position of the ol, that is 1, and then we write ol, right? So what have we done? By writing this, putting the hyphens to separate it out, and the functional group is written later, and the position, the locant, is added here. You know, at earlier times, like when I was a student, this was not done. We used to write it as 1 propanol, 2 propanol. I remember in the previous video when I was talking about glycerol, I named it as 1, 2, 3 propan triol. Again, it is old habits die hard. The current method is IUPAC changed this method of writing 1, 2, 3 propan triol because it was decided that we will write the locants exactly where the functional group is, so that there is no confusion at all. And actually it is a better method of writing it, so I stand corrected here. I should have named it propan 1, 2, 3 triol. Anyway, what I'm emphasizing here is that in the current IUPAC nomenclature, you will write the name of the parent hydrocarbon, put a hyphen, write down the locant, the place where the alcoholic group is attached, and then write the name of the alcoholic group, which is OL, the suffix. So come to the third compound, CH3, CH, CH3. So this is also propane. This also has 3 carbons. So this is also propan, and it is also ol. It is propanol. In the common nomenclature, whenever you have the second carbon attached to the main chain, or the second carbon having the functional group like this, we call it an iso compound. When you have an alkyl group which is attached to the main chain by the second carbon, not by the first carbon, that group, alkyl group, is also known as an iso group. So here the functional group OH is attached on the second carbon. Using that logic, this is called isopropyl alcohol, right? But in IUPAC nomenclature, we know that this is propane, so the parent hydrocarbon was propane, and this is propanol, but the ol is at which position? The ol is at 1, 2, 3. If I count from this direction, it is the locant is 2, and if I count from this direction also 1, 2, 3, the OH is on the second carbon. So irrespective of which direction I count from, the locant for OH is 2. So what do we write? What will its IUPAC name be? It will be propan 2 ol. It's propanol, but the ol is present on the second carbon, right? Next, CH3, CH2, 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 OH. Now this is the butyl group. The parent hydrocarbon is butane. One hydrogen of butane has been replaced by OH. So in the case of common nomenclature, this is a normal compound. Normal means it's a straight chain compound. So it is written as normal butyl alcohol, just as we had the normal propyl alcohol. So this is normal butyl alcohol, but in the case of IUPAC nomenclature, this would be butanol, but the ol would be on the first carbon. We'll start counting from this direction. So it is on the first carbon. So we'll call it butane -1 ol. So it is butane 1 ol. Remember, when you're writing the IUPAC nomenclature, you always start the name with a capital letter. But later, whatever is being, if there are hyphens, you're putting locants or whatever, the rest of the name, if you're writing some parts of it, it is never a capital. Only the first alphabet is a capital. Just like my name is Seema, so S is capital. The EEMA remain small, the lowercase alphabets. So we were doing butanol. So according to IUPAC nomenclature, this becomes butane 1 ol. Why 1 ol? Because I would choose to count from this direction. I will try to give OH the lowest locant. If I had counted from this direction, the ol would have been on the fourth carbon, which doesn't make sense. I want to give it a name. I want to give it importance. Like if I want to give you importance, will I put you at the fourth position, or would I keep you on the first position? So the more important you are, the further ahead I would like to notice you. So the OH is on the first carbon, so it is butane 1 ol. Fifth compound, CH3, CH, CH2, CH3. And CH has an OH. Again, the compound consists of 4 carbons, right? It consists of 4 carbons and the OH is attached to the second carbon. Now what is interesting is that whenever the functional group is attached to a carbon which is also attached to 2 other carbons, we call it a secondary compound, right? And when a compound, a functional group is attached to a carbon which is connected only to one other carbon, for example here, OH is attached to this carbon which is attached to only one other carbon. The carbon to which the OH is attached only to one other carbon is a primary carbon. If you have this carbon which is attached to the functional group is attached to 2 other carbons, it is a secondary carbon. And if there is a carbon which is attached to 3 other carbons, it is a tertiary carbon. So now in this case, we call it secondary butyl. It is butyl because butane should have been the parent hydrocarbon. So it is secondary butyl alcohol in common nomenclature, right? This is secondary butyl alcohol. And in IUPAC nomenclature, this is butanol, but the ol is attached to the second carbon. So it is butane 2 ol. I hope you are understanding the logic behind the naming. IUPAC nomenclature, I feel, is easier, and common nomenclature can be a little complex, but the good part is that it's not compulsory for you to learn all of the common nomenclature. yet having a little idea helps. So we've done butane 2-all. Let us come to the sixth compound, CH3CH. There's a branch CH3, CH2OH. Now 1, 2, 3, 4. This is also butane. The parent hydrocarbon, if you see, has got 4 carbons, and it is an alcohol. So according to common nomenclature, this should be a butanol. But I told you, whenever the second carbon is the one which is branching out, we call it an iso compound. When the second carbon is branching out, or there's a methyl group attached to the second carbon, it is branching out, we call it an iso compound. So this becomes isobutyl alcohol. It becomes isobutyl alcohol. Just as here we called it isopropyl alcohol. And here basically, you know, it's just a way of writing. I could have written the CH3 here and the OH here. So it would appear kind of similar, and then the confusion would be less. But they are basically similar compounds. The OH is attached to a CH, and the OH is attached to a CH in isopropyl group, or I would rather suggest that in the case of, there is no proper rule being followed here. Do you see? In isopropyl, the CH had the OH, and in isobutyl, the second CH has a methyl group, and the CH2 here, the terminal CH2 seems to be having OH attached to it. So there can be a little confusion, so I would suggest just memorizing the isopropyl group and the isobutyl group. Right? Isopropyl is when the second carbon has the branch, and isobutyl is when the second carbon of the butyl in common nomenclature has a methyl group attached to it. But in Iupac nomenclature, this is not a butane at all, because according to Iupac nomenclature, the longest chain here would consist of 1, 2, 3 carbons, and this methyl group is only a branch. We always choose the carbon which has the functional group to be a member of the chain, the main chain. So this becomes propanol, and the methyl group is attached to propanol. Then what was the second thing that we have to keep in mind? When we are giving the locants, we should count from that direction in which the functional group gets the lowest locant. Now, methyl group here is a substituent, while the OH, that is the alcoholic group, is the functional group. So which is more important? The alcoholic group being the functional group is more important, and the substituent is not so important. So I will count from this direction, not from this direction. I will not say it is 2-methyl, 3-propanol. I will not say that. It is 2-methyl, 3-propan, 3-all. I will not name it like that. I'll count it from this direction. I'll say it is 2-methyl. It is 2-methyl, but it is propan 1-all. So it is 2-methyl, propan 1-all. Do you get me? What is the logic? The OH group is more important because this is the functional group. The methyl group here is only a substituent. The parent hydrocarbon consists of only 3 carbon atoms, so it is propane. So I count from this direction, so this becomes propanol, propan 1-all, but a methyl group is attached to the second carbon, so we say it is 2-methyl, propan 1-all. Do you see where the name started? It was a capital letter, but even if I am writing propanol, I do not put a capital there. The name starts first in the beginning with a capital letter, and that's it. Let us now come to the next compound, that is the 7th compound. This has CH3C, CH3, CH3OH. Right? What do we see here? According to common nomenclature, we count the total number of carbon atoms. So this compound appears to have 1, 2, 3, 4 carbons. So it is a butyl alcohol. But how do we specify, how do we tell that the butyl alcohol is such that the OH is attached to this carbon? As I told you here, that when the OH is attached to a carbon which is attached to 2 other carbon atoms, we call it a secondary butyl alcohol, if it is butyl. In this case, the OH, that is the alcoholic group, is attached to a carbon which is attached to 3 other carbon atoms. And it is a butyl alcohol, a total of 4. So obviously the OH is attached to the carbon which is attached to 3 other carbon atoms. So if I say it is tertiary butyl alcohol, you can imagine this structure. That OH is attached to a carbon and that carbon is attached to 3 other carbon atoms. So since there was a total of 4 carbon atoms, obviously this would be the structure of tertiary butyl alcohol. That is common nomenclature. But if we come to the IUPAC nomenclature now, take a look. That in IUPAC nomenclature, what do we say? We choose the longest chain to be the parent hydrocarbon. And the longest chain should contain the functional group. So the OH group is attached to this carbon. So this carbon is a part of the main chain. So if I take this carbon to be a part of the main chain, I can imagine 1, 2, 3. 3 carbons. It can be propane. If I choose these 3, the longest chain, this also becomes propane. It is basically a symmetrical structure. We can assume that 1, 2, 3 is the parent chain and the second carbon has 2 substituents. One is a functional group, that is the alcoholic group, and the second is the methyl group, which is the substituent. So our chain consists of 3 carbons. So we say this is propanol. It is propanol. But now it is propanol to which methyl group has been attached and the alcoholic group, of course, it is all. So we have to now give the locants to both the alcoholic group and the methyl group. So we will say that this is propane. First, let us give the locant for the methyl group. 1, 2, 3. The second carbon has both the methyl group and the alcoholic group. So the locant for both the alcoholic group and the methyl group is 2. So it will be 2 methyl propan 2 all. 2 methyl propan 2 all. Right? Whenever you're giving the number of the locant, put a hyphen, write the number, put another hyphen, continue with your name. So this would be 2 hyphen. In the beginning you don't start with a hyphen, so it is 2 methyl propan hyphen 2 hyphen all. So it is 2 methyl propan 2 all is the name of the compound. Come to the 8th compound now. This I had already done in the previous video also. CH2, CH, CH2, and there are 3 alcoholic groups on each carbon. It is propan triol. The common name of this compound is glycerol. Industrially, it is used very commonly, so it is called glycerol. You know, glycerine that is made out of this glycerol. So it is glycerol, and in IUPAC nomenclature, it is propan, right? It is propan 1, 2, 3 triol. There are 3 ols, so it becomes propan hyphen 1, 2, 3. These are the locants hyphen triol. That there are 3 ols. So that was glycerol. If you have alcohols which are cyclic, if you have cyclic hydrocarbons which are not aromatic hydrocarbons, they are not benzene ring and all, they're just cyclic. If they are cyclic, how do you name them? When a compound is cyclic in nature and it has an alcoholic group attached to it or any functional group attached to it, we name the cyclic compound as you would with the prefix of cyclo. For example, you have cyclopentane, cyclobutane. If there are 4 carbons making a cycle, 5 carbons you call it a cyclopentane. If there are 6 carbons you call it a cyclohexane, 7 is cycloheptane and so on. Well, you just put the word cyclo before it. But if it is an alcohol, then that carbon which has the alcoholic group is treated as the first carbon and the rest is the same. So this is cyclohexanol. We are assuming there is no locant, then there is no need, because automatically we are assuming that the carbon which has the alcoholic group is the first carbon. Just as we ignored here in methanol, there was no need of putting a locant. We know there is only 1 carbon and that is the carbon which has the alcoholic group. And in propan 1 all, we do specify the 1. Although if you do not specify the 1, it is understood that it is the locant is 1. Whenever you do not write the locant, it will be understood or it will be assumed that the locant is 1. So this is cyclohexanol. And if there is a methyl group on the second carbon, there's a methyl group on one carbon and OH group on the other carbon. How would you name it? You would, whenever you have a functional group and a substituent, a functional group is more important than a substituent. So when you're naming it in order of priority, you would give priority to the alcoholic group. So you'll say this is cyclopentanol, but the methyl group is a substituent which has been attached to the second carbon. Why second carbon? Because this carbon automatically is the first carbon. So it'll be 2-methyl cyclopentanol, right? So this was the naming of alcohols. You can use many more examples, look into books and try to name more alcohols. We now come to phenols. How do we name phenols? Phenols are nothing but benzene derivatives. When there is a benzene ring and the OH group is attached to one of the carbons of the benzene ring, it is called a phenol. So phenol and all its derivatives are named as phenols. It becomes a class of compounds which are called phenols, or the alcoholic group attached to a benzene ring. How do we name them? The simplest phenol would be a benzene ring to which an OH group has been attached, right? So the simplest hydroxy derivative of benzene is phenol. The simplest derivative, that is the simplest compound that you can make with an OH group and a benzene ring, would be phenol. This word phenol is accepted both in common nomenclature and in the Iupac nomenclature. Phenol is used in Iupac nomenclature too. So when you have phenol and there are other substituents attached to it, we just call the compound phenol, assuming the benzene ring and the OH to be the parent and the other group as the substituent which has been attached wherever. In comparison to the OH group, assuming the OH is always the first carbon, even in the case of phenols. So this compound, phenol, is accepted both in common and Iupac nomenclature. For di-substituted groups, that is, if you have two substituents, the alcoholic group and the other, in common nomenclature we use ortho, meta and para prefixes. Ortho means a substitution in first and second carbon, meta means a substitution in the first and third carbon, and para means a substitution in first and the fourth carbon. So let us now see how is the naming done. This is phenol. The common names are given on top and the Iupac names are given in the bottom. Phenol is benzene ring to which OH has been attached, so we use the same name in the common nomenclature and in the Iupac nomenclature. When you have a methyl group and an OH group attached to benzene, the compounds in common nomenclature are known as cresols. They are called cresols. A cresol is a compound in which there is the alcoholic group and the methyl group attached. Then we are not calling it phenol, but this is only common nomenclature. In Iupac nomenclature, we treat the phenol. Phenol is the word that has been accepted in Iupac nomenclature, not the other words like cresols, resorcinol, hydroquinone. These are not added. Only phenol has been accepted by Iupac nomenclature. So whatever you will be writing would be derivative of phenol. So in common nomenclature, this is an ortho compound. Why? Because the substitution is on the first and the second carbon, so we call it orthocresol. If it is first and third, substitution is from distant by one carbon, that is one carbon has a methyl group, second carbon has nothing, third carbon has OH. So, or you will say OH is the first carbon and the methyl is the third carbon, whatever. This is metacresol. Whenever substitution is on the first and third carbon, it is meta. First and second carbon is ortho, so it is orthocresol, metacresol, and this becomes paracresol. That is common nomenclature. In Iupac nomenclature, you will call all of these phenols, and the OH will be the first carbon, right? So if this is the first carbon, this is phenol, this is the first carbon, then methyl group you will start counting in this direction to give it the lowest locant. So methyl is attached to the second carbon, so we'll say it is 2-methyl phenol. Am I clear? It is 2-methyl phenol. Here OH is the first carbon, so methyl group is how much away from it? This is carbon 1, carbon 2, carbon 3. So this is 3-methyl phenol. 3-methyl phenol. We do not use the term cresol in Iupac nomenclature. So this is 3-methyl phenol. Take a look here now. This is OH is the first carbon, second, third, fourth, or first carbon, second, third, fourth. It is 1,4 substitution. So we call it 4-methyl phenol. And there is no need of writing any locant for phenol because it is understood the carbon containing the OH group in phenol is the first carbon. Right? So this is how you would be naming phenols. Now if the compounds have dihydroxy derivatives, dihydroxy here you see one was they were di-substituted, the compounds, but one was OH, the other was a methyl group. It could have been a nitro group, it could have been any other, it could have been a chlorine, so it could be any other substituent, but the two substituents were different. If you have alcohols or phenols which have two alcoholic groups, two OH groups, now we do not call them phenols. Because if you call it phenol, then if I let us say both of these were OH, like in this, both of these are OH. If I call it phenol, which one do I accept as carbon 1 and which one do I accept as carbon 2? You know, it becomes difficult to assume which one are you assuming as the main, and you cannot treat them differently. After all, both the alcoholic groups are identical. Your name should also show that they are identical. If I call it phenol, it would mean that the phenol is a compound and the OH is a substituent, which is not so. Both the OH groups are equally important and are going to affect the properties of the compound equally. So we cannot name them as phenols. When you have dihydroxy derivatives, that is hydroxy, there are two OH groups in the benzene ring, then we name them as benzene. In the Iupac nomenclature, we call them benzene 1,2-diol, right? Just as we name the these methanol. So it is benzene hyphen, there are two alls, so the locants for both of them, benzene 1,2-diol. This is, if this is if this is the second one that we have to name, then this is benzene, this is 1, carbon 2, carbon 3. Or if I count from this direction also, it is carbon 1, carbon 2, carbon 3. So either way I count it, I will get benzene 1,3-diol. And this would be benzene 1,4-diol. That was common nomenclature. In Iupac nomenclature, we know that this is an ortho compound, this is a meta compound, and this is a para compound. But these three dihydroxy derivatives have been, they are used pretty commonly in industry, therefore they have been given these common names, that is catechol, resorcinol and hydroquinone or quinol. These are their common names, and since these common names are pretty famous, they are mentioned in the book, but there is it is difficult to remember compounds, and it is not actually compulsory to remember compounds by their common names, because when you are from another country and you go to another country to look for a chemical, you are not expected to know the common names. But if you know the Iupac nomenclature, you will always get the right compound, because the Iupac nomenclature will give you the exact chemical composition of what exactly the molecule is like. Because the Iupac nomenclature is based on the structure of the compound. So you would know you should know the Iupac name. Anyway, but still, just to throw in that little information that benzene 1,2-diol is called catechol, benzene 1,3-diol is called resorcinol, and benzene 1,4-diol is known as hydroquinone or quinol. So this was the nomenclature of alcohols and phenols. In the next video, I'll start with the nomenclature of ethers, and then we'll do an example, a solved example, and then the in-text questions. So with this, I'll wind up this video. If you wish to watch other videos of this chapter, click the link that appears on top. If you found this video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.